All right, so for example number 2, we're going to find a polynomial from the given zeros. So what they did is they said that the polynomial had the following zeros: x equals -3, x equals 4, and x equals 2 minus I. Now, if we take all of those and set those equal to 0, what I do is I add the opposite to each side. In other words, x plus 3 should equal 0. X minus 4 should equal 0. And then x minus 2 minus I should equal 0. Okay? And so those must be factors. Now here's the only thing. When they list it like this, complex numbers never travel alone. They're never by themselves. So the complex numbers always travel in pairs, and they're usually conjugate. And so if I push that negative sign through, I get -2I plus I. Okay? Now what I need to do is I need to do the conjugate of that. So I have to be careful. In other words, what I need to remember is that this 2 plus I is also a factor. And now when I push that through, I get -2 minus I. Okay? So now to write the polynomial, I just have to, in other words, what I have to do is I have f of x is equal to x plus 3 times the quantity x minus 4 times the quantity x minus 2 plus I times the quantity x minus 2 minus I. And so I have to FOIL those out. Well, I'm gonna address these first. So if I say x plus 3 times x minus 4, I'm gonna get x squared plus 3x minus 4x minus 12. And so when I combine like terms, I'm gonna get x squared, and remember we got to combine like terms here. -4 plus 3 is -1, so that's going to become -1x minus 12. So that is just this times this. When I multiply or FOIL those, I'm going to end up with x squared minus 6 minus 12, or minus x minus 12. Now I got to do the same thing with this. This one's a little trickier. Okay. So this one I'm going to write off to the side. Well, maybe I could squeeze it in here. So I need to FOIL this. So I'm going to say x minus 2 plus I oh wow, this looks crazy. And then this is going to be x minus 2 minus I. So I have x squared. Then I'm going to have minus 2x. Then I'm going to have I times x. Then I'm going to have minus 2x. Then I'm going to have -2 times -2 is a positive 4. Then I'm going to have -2I. Then I'm going to have -xi. Then I'm going to have positive 2I. And then I'm going to have -I squared. So that's a whole bunch of stuff. But if you guys are playing along at home, go ahead. If you guys are playing along at home, you'll see that some things cancel. In other words, my positive ix cancels with the negative xi. And then I have a positive 2i that cancels with the negative 2i. I do have like terms here. I have negative 2x and negative 2x, and I have x squared. So I have x squared minus 4x, and then I have 4 minus I squared. But remember, negative I squared is the same as negative, what's I squared equal? Negative 1. So the negative of negative 1 is just positive 1. So I really have 1 plus 4, which is 5. Do you guys see where I got that from? Does everybody see where the 5 came from? Okay. So now I just need to multiply these two out, and I'll get my answer. Man, this is a lot of work. So I'm going to say x squared minus x minus 12 times x squared minus 4x plus 5. So I got x to the 4th minus x cubed minus 12x squared minus 4x cubed minus, oh no, positive 4x squared, positive 48x, 5x squared, and then minus 5x, and then negative 60. Is that right so far? Now usually if both polynomials are written in descending order, you'll see a pattern of the like terms showing up in the diagonals of the grid. And so those are, we just need to combine those. And so what I end up, or I should end up with, is that my f of x, which was all this stuff up here, then became all of this stuff right here. Should be equal to x to the 4th minus 5x cubed. Negative 12 plus 9 is minus 3x squared. 48 minus 5 is positive 43x minus 60. And that's pretty much it. Are there any questions? No? Okay, cool.